This chart that's available to you in Module 1 is a document called Choosing a Statistical Test. One of the things that we're going to spend quite a bit of time on throughout this course is the idea of being able to compare groups or using data to find out information. And we will have a discussion about the types of data. There is ordinal data, which is also known as rank or score data. There is also types of data called interval or ratio. When it says Gaussian on here, what that means is normal distribution, which we'll have a video about the normal distribution. And then the other types of data is the binomial, or two possible outcomes, male, female, yes, no, that kind of thing. So that's one part of this matrix. The other part of the matrix has to do with what is it that we're trying to do. So for example, if we want to describe the average salary of a group of administrators, we do that with interval or ratio data, which is normally distributed, and we do that with the mean and a standard deviation. If we want to use survey information, that is rank data, that's a different type of data. We could still describe one group doing that, and we use things like mean, median, mode, interquartile range to describe that. If, for example, we wanted to compare one group to a hypothetical value, there is a specific type of test that we use to do that. Now, if we want to compare IQ data is interval or ratio data. It's Gaussian, it has a normal distribution. The test that we'd use to do that is this one sample t-test. If we want to compare a class's response on a to job satisfaction survey in relation to some national norm, so now we're comparing one group to a hypothetical value, we use something called the Wilcoxon test. And this is what continues to work its way down. If we want to compare two groups that really don't have anything to do with each other, that's called an unpaired t-test or an independent t-test. But we only do that if it is interval or ratio data. If we want to compare two groups, for example, if we want to compare responses on a survey and we want to compare college graduates to high school graduates, those are two independent groups. But because it's survey data, this ordinal data, this rank data, there's the test to do that is called the Mann-Whitney test. So as we work our way down through this semester, we'll continue to look at the different types of tests, and we'll start with everything that goes through this, well, most of everything that goes through this column. We're going to start with just the interval and ratio type data and looking at these types of comparisons. And then towards the end of the semester, at the end of the course, we'll deal with the same things going down the middle of the column and the ones going down the right-hand side of the column. Now, what you'll learn throughout this course is very often, actually quite frequently, we will see researchers using a test like this, the paired sample t-test, also known as a dependent sample t-test. But they're doing that with ordinal data. For example, they will have a survey where they're comparing two groups that might be paired together, the male and female part of a relationship, like in marriage, for example. When really what they're supposed to be doing is the Wilcoxon test. Now, the question asked is, well, why do people do that? They do it because, honestly, they don't know that there is this test. The wrong thing has been done so much. We think it's the right thing now. This has been done so much with this kind of data up here that we think that's the right thing to do. Now, you may ask, well, what difference does it make? It makes a big difference. We can't really know anything about statistical comparisons. For example, does one group of people make more money than another group of people? You can't look at that and just look at the means and say, well, if one group has a mean higher than the other group, then obviously there is a difference. That's not true, because you also have to look at the standard deviation and do a comparison with statistics to find that out. So we end up with people using the wrong test to do that uh, in a lot of cases, and you can come up with a different answer. That if you use the correct test, you get a different answer than if you use the incorrect test, which introduces something called a type 1 error, which is when you say something's true that's not, but we'll get to that in a few more modules.